Good afternoon, everyone. I am Rishika Gaur, the host for today's event. Before starting the event, I would like to give you a brief introduction about ACM. You all know that it is a global community for advancements in science and technology. It organizes various activities and has around 200 student chapters across different nations, of which CCET ACM and ACM-W is one of them. At the CCET ACM and ACM-W student chapter, we aim to grow and involve more tech enthusiasts, including women, who share their experience and knowledge of their domain with other budding technocrats. Currently, we are working on research and development with also a focus on web development, competitive programming, and designing. Our overall goal is to envision building a community of like-minded people who love to code, collaborate, and have fun in tech-savvy society. Keeping the same in mind, we also invited interested speakers to discuss and share their skills in their expertise with other individuals and technology associated people. Today's speakers are Uday Madan and Lalit Kumar from Department of Computer Science and Engineering, Chandigarh College of Engineering and Technology, Chandigarh. Now, without taking much time, let's start the workshop. Over to you, Lalit.
Thank you, ma'am. Thank you for the introduction. Hello, everyone. This is Lalit Kumar, and today we are going to learn about Arduino. So, just a second, let me present my screen. So, hello, everyone. This is Lalit Kumar,
Hello everyone, I'm Uday Madan.
and today we are going to learn about Arduino. So, what is Arduino? Arduino is a single circuit board which consists of different interfaces or parts. The board consists of a set of digital and analog pins that are used to connect various devices and components which we want to use for the functioning of electronic devices. It simplifies the process of creating any control system by providing the standard board that can be programmed by and connected to the system without the need of any sophisticated PCB design and implementation. It is an open source hardware. Anyone can get the details of its design and modify it to make his own one for himself. So, the main component of an Arduino is a microcontroller. The Arduino can sense the environment by receiving input from variety of sensors and affect its surrounding by controlling lights and motors and other actuators. Now, what is a microcontroller? The microcontroller is a small and low power computer. Most of the microcontrollers have a RAM, a CPU, and a memory storage like other computer systems. The general purpose input output pins present on the chip help us to control other electronics or circuitry from the program. The famous microcontroller manufacturers are Microchip, Amtel, Intel, Analog Devices. It is used to control purp- it is used for control purposes and for data analysis. Now the features of Arduino. Arduino programming is a simplified version of C++ which makes the learning process very easy. The Arduino IDE is used to control the functions of boards. It further sends the set of simplifications specifications to the microcontroller. Arduino does not need an extra board or piece to load the new code. Arduino can read analog and digital input signals. The hardware and software platform is easy to use and implement. Now the types of Arduino. The first one is the Arduino UNO, which we will be using in our workshop later. The second is Arduino Duo. The third type is Arduino Mega. The fourth is Arduino Nano. And the fifth one is Arduino Bluetooth. Now, the, about Arduino UNO. This is the brief diagram of an Arduino UNO. Let's look at some of the key components of this board. The first component is the USB type port, which is used to connect the Arduino to a computer or a mobile phone. This port can be used to power the Arduino board as well as to upload the program which will be later executed by the microcontroller. The second port is the DC power port. Its sole purpose is to power the Arduino board. The third are the power pins. They are used to provide power to the other components that are to be connected to the Arduino board for making any project. The next are the analog pins. These pins are used to provide input and output, analog input and output. The next are the digital pins. These pins are used to provide digital output and can be used as a digital input also. Now, this is the microcontroller, which is the brain of this whole Arduino board. The features of Arduino UNO. The Arduino UNO features 80 mega 328 microcontroller. Its operating voltage is 5 volt and 3.3 volts. The standard recommended input voltage for an Arduino UNO is 7 to 12 volts. It can withstand up to 20 volts, and there is also a voltage chip inserted on the Arduino UNO which prevents the board from getting fried if higher voltage is applied. There are 14 digital input-output pins, out of which 6 pins are pulse width modulation pins, which help to control the output of the pins. For example, these pins can be used to control the brightness of an LED, the speed of a DC motor, etc. The DC current for input-output pins is 40 milliampere, and the DC current for 3.3 volt pin is 50 milliampere. Arduino consists of a flash memory of 32 KB, out of which 0.5 KB is used by the bootloader. It has a static RAM of 2 KB and an electrical erasable programmable ROM of 1 KB. It operates on the clock speed of 16 MHz. Now let's look at the coding structure for Arduino. The coding structure for Arduino consists of two parts. First, the void setup. The void setup is used to indicate the initial values of the system on starting. The second is the void loop. This contains the statement that will run whenever the system is powered after startup. Now let's look at some coding basics. They are just for the revision, as you all should know them. They are the basic coding basics that are used when you learn any coding languages like C language or C++. So let's start. The first one is data type and operators. The second is intro to functions. Third is control statements. And fourth are loop statements. First, the data types. There are basically 4 primary data types in any programming language, which includes integer, float, boolean, and character. The description for each is given. I hope you all know this. If you have any doubt, you can ask. So let's move on. Now the operators. There are basically 3 types of operators in any programming language. These include unary operator, binary operator, and ternary operator. The unary operator works only on single operand, while the binary operators work on 2 operands, and the ternary operator works on 3 operands. Each type is listed in the table. If you have any doubt, you can ask. So let's continue. Now the functions. There are 2 types of functions, one with arguments and the other without arguments. The functions that are with arguments are declared and defined with a parameter list and the value for parameters are passed during the function call. The functions without arguments do not have any parameters included and no value is passed during the function call. The example of declaration and function call is listed on the screen. Next are the control statements. The first are if-else conditioning statements. The syntax for the if-else condition statement is shown on the display. If you have any doubt, you can ask. The next is the switch control statements. The switch control statements syntax includes the keyword switch, then a variable, and the variable then is compared with each case. For example, if the variable is equal to 1, then case 1 will be executed, or if it is 2, then the case 2 will execute, or if the variable doesn't match any condition, then the default case will be executed. The default case is also optional. You can it depends on you what you want to do if none of the variable that you give doesn't match any of the cases. The next are the loop statements. There are basically three types of loop in any programming language. The first is for loop, the second is while loop, and the third is do while loop. The syntax for each loop is listed on the screen. If you have any doubt, you can ask. Okay, so let's continue. Next is an example. So let's look at an example of LED blinking. So what functions we will use to make a blinking LED with the help of Arduino? So the functions used include a pin mode. The syntax for this function includes a pin number and a mode. The mode can be either output or input, which can be passed from the highlighted portion of the Arduino board. The pin number can range from 0 to 13. This pin number will be acting as either the input or output. The second is the digital read, and this function is used to read the state of any digital pin that either it is high or low. The third is digital write. Its syntax includes a pin number and a mode. The mode can be either high or low. This function is used to turn on the LED or off the LED. For example, if we connect an LED on let's say pin number 7 and let's pass the mode high to the function, then the LED which will be connected on port number 7 in the highlighted area here will glow, and if the mode is set to low, then the LED will stop glowing. The next is the delay time. It decides the delay which will be present between each glow of the LED. The time is passed in milliseconds. So that's all from my side. Now let's move on to the second part of the workshop, which is hands-on deck session with Uday Madan. Over to you, Uday. Thank you, everyone.
So thank you, Lalit. So hello again, everyone. Uh, I think everyone have played with a remote control car in his or her childhood. So in today's session, we will be making a remote control car with Arduino UNO. You can make it in a real life if you have a physical Arduino board, but we'll be using an online simulator today, that is Tinkercad, because of the limitations of this online setup. So let me share my screen. So as you see, there is a I have opened the Google, and you have to just type Tinkercad login here, and you have to just open the first link. So this is the simulator where we can design our circuits. So we have to go to left hand side. There is a circuits tab. We have to click on it, and we have to create a new circuit. Till the circuit is being opened, I will show you the components we are going to use today. So these are the components: Arduino board, Arduino UNO that Lalit told you before, an LCD display, a resistor of 220 ohms, a potentiometer of 250 kilo ohms, a IR sensor, a DC motor, a micro servo motor, and two red LEDs. Okay, and this is the circuit diagram of the circuit we are going to make today. You can screenshot it, or I will send you later if you want. So let's go back to our Tinkercad. So this is the starting window. Let me make you familiar with this platform. So on the left hand side at top, you can name the project you want to work on. So like I'm naming it ACM uh, Arduino workshop center. So it's renamed. Here are in the right you have the component window where you can see different components which you can use in your circuit. So first of all, we will be having an Arduino Uno circuit. So we'll be using this today. And as you can see, it has 13 digital pins. These are the digital pins, and 6 analog pins, a 5-volt pin, which will give 5-volt current to the circuit, a 3.3 volt pin, 2 ground pins, a reset pin, and many more pins you can see. After that, we'll use a breadboard here. So first of all, I will tell you what a breadboard is. So a breadboard has 30 columns and 14 rows. So first two rows are donated to positive and negative terminals of the Arduino. So we can connect the positive and negative to this, and these all are connected to each other. So like if I give positive to this row to column 1, so I can access the positive from anywhere, any column in this row. So all are connected to each other, and same with the negative. If I give negative to row 1, column 1, I can access negative from any row, any column. And like top, there are two rows of positive and negative in bottom. We can have positive and negative from here also. And in middle, there are in this columns are connected, row is connected to each other, and these columns are connected to each other. Like you can see the highlighted part, all those terminals which are highlighted are connected to each other. Like F, G, H, I, J are connected to each other in row or column 1, column 2, column 3, as. So if you have any doubts, you can ask me now. Otherwise, we'll move on. So no doubts. Okay, so we'll be giving a 5-volt input in our positive row. So we'll be connecting through a wire and attaching to it here. Okay. So we'll be using an convention in our whole circuit that positive is red color and negative is black color. And you can make wire just by clicking on the terminal, and your wire will start. You can make a joint by another click, and after that you can, after reaching the another terminal, you can click again so that the wire will be made. Now we'll give a black color to it. You can give a color by you can see the top left, we can give a black color to it. So I have connected 5-volt to positive and ground to negative. So now these two are connected. Now we'll connect these two with the help of these. So I'm giving a positive to this positive, red color to it, and negative to negative, black color to it. So our breadboard is now ready. We can access positive, negative anywhere we want. Okay. So now we want a LCD display here. So we'll search LCD and we need a LCD 16 into 2 screen here. So you can do it with me if you want. So I have chosen a LCD display 16 into 2 and we'll make its connection now. So in the LCD display, as you can see, there is a ground terminal, a power terminal, a contrast terminal, and there are many terminals, LED, anode, cathode, etc. So we'll start making the connections now. So first of all, we'll connect the ground with the negative here. As I told you, this all is connected to each other, so I can access the ground from any of the pin here. So I've connected it to here. And now we'll connect the power to the positive terminal here. Okay, and we'll give a red color. Now LED anode, ground and power are connected. Now there are LED cathode and anode. So anode is positive terminal and cathode is negative terminal. So we need a resistor first. So I will type resistor in my component window, and here is the resistor. So you can place it here and you can rotate it from top left. So I've rotated it and set the resistance to 220 ohms. So now I will connect the anode with the resistor and eventually with the positive terminal of our breadboard, and cathode to the negative terminal of our breadboard, and give it a black color. Okay. So now all positive negative are connected, and here is a read write pin. We have to connect it with the ground terminal. So we'll connect it to the ground of our display. Okay. Now here we have a contrast pin in our LCD display. So we can set the contrast of this LCD display using an potentiometer. Okay, so potentiometer is here with us, with resistor. It is present here. You can find that a potentiometer is a type of resistor whose resistance can be changed at the turn of the knob. Like I am placing it here on my breadboard. So we'll set it to 250 kilo ohms. It's right. Okay. So now a potentiometer, we can change its resistance by turning this knob now present on it. I will show you later how we can change the resistance. So we can change the contrast of the LCD display by changing the resistance of this knob. So it has three terminals, terminal 1, terminal 2 and a wiper. So terminal 1 I will connect firstly with positive. So positive we have it below, so I'm connecting it to positive, and I'm connecting terminal 2 to negative. Okay, and after that the wiper we have, I'm connecting it to the contrast pin I have told you above, below. So I'm connecting it to the contrast pin and giving it any color like purple. So we'll be controlling this contrast of our LCD display using this swiper. So now our contrast pin is set. Now we have an enable pin in our LCD display. So we'll be connecting this enable pin to pin number 11 in our Arduino board. So this is pin number D11, you can see. So I'm connecting it to this. Okay. Oh, giving it any color, brown. And we have a register select pin here. We will connect it to pin number 12 in our Arduino board. So yellow, or we can give it brown. You can give it any color. These are the wires, so color doesn't matter. After that, we have 8 D pins in our LCD display. DB pins. So we'll be using 4 DB pins today. That are DB7, DB6, DB5, and DB4. Okay. So we'll be connecting these 4 DB pins to our 4 pins of Arduino board. That is 2, 3, 4, and 5. So connecting DB7 to second pin. Giving it a yellow color. DB6 pin to third pin of the Arduino, DB5 pin to the fourth pin of Arduino, and DB4 pin to the fifth pin of Arduino. So till now all our connections are ready for the LCD display. This will help us to check whether our code is going in the right direction. So I have placed this LCD display to check our code is right or not. So we'll write a code to test this is working fine or not. So for coding, you have a right on top right, you have a code toggle editor. So you can write in blocks or text, but we will be using text today as many of us know C++ language, and Arduino also uses C++ language. So we don't know this, we don't want this code, so we'll be deleting it. So as Lalit told you before, there are the code structure of Arduino contains two basic functions. First one is void setup, and second one is void loop. So the setup function basically does the setup of the components we are using. Like I'm using an LCD display or something like that. So it will do the setup. We'll write the code of setup in it. It will run at the starting of the code and only uh, once at the starting. And the void loop function will continuously repeat itself. After it ends, it will start again, and it like we are making a circuit. So we need a sensor's input at every point of time, and the sensor input changes. So we need to loop some code. So that code is put in this loop. Okay. So first of all, test. We'll be testing the LCD display. So we'll be writing a code here. So same like C++, we'll first include an library for liquid crystal display, that is LCD. So we'll not include here IO stream or stdio.h, because this compiler already has those libraries. So if we need anything extra, we have to include those only. So we'll firstly include uh, liquid crystal.h library. So this is the library for the LCD display. Okay. So now this library has a class name liquid crystal. We'll make an object of that class. So it's like just you make an integer in C++ and you give it a name. So I am making a liquid crystal and giving it a name LCD. Okay, so we'll be calling this liquid crystal display as LCD, and we have to give it arguments like which I have connected this to which pins of the Arduino board. So I have connected this to 12, 11, 5, 4, 3, 2. So I will be adding this. So 12, 11, 5, 4, 3, 2. So I have added those pins which I have connected to the liquid crystal. So I have defined an liquid crystal object using the class liquid crystal which is defined in this library. Okay. So now I told you that we'll be doing the setup in this word setup. So firstly we'll be uh, doing a beginning our LCD display. Okay. So we'll write LCD, which is our object we have made, and we will write a function namely dot begin, which is defined in the library I have included above. Okay. So it will begin the LCD, means start the LCD, and in which we have to pass the arguments like how many rows and columns we are using of the LCD. So as I have took 16 into 2 LCD, so I have to write 16 comma 2 here. So our LCD will begin after this. Now we have a function namely LCD dot print, and we can print anything in it. So I will print system star page. Okay. So I've written system started here. So we'll start the simulation now to test everything is working fine or we have done something wrong. I've started the simulation. So now you can see our system, like it doesn't print anything. Okay. So I told you in the starting that we will set the contrast of our LCD using this potentiometer. So I will change the resistance of the potentiometer. Like I told you, we can change the resistance by moving this knob. So I will move this knob, and at some point, our system will start. Like at this point, you can see the contrast is low, but we are reaching to full contrast slowly. And at this point, we have full contrast. Okay, so we can control the contrast of system using this potentiometer. Now I have configured the resistance that our system needs to start the LED. I have set it the contrast here. Okay, I will not change it now because our system is started. So this is the full contrast. So any doubts you can ask me now, because one part is over of setting up the LCD display. Now after that part 2 will start. Any doubts you can ask me now. So no doubts. Okay. So now we are making a remote control car. So we will be using a IR sensor and IR remote, which we generally have in our TVs. IR remote. So infrared, you can say infrared. IR full form is infrared. So I will type IR in the component window, and we have IR sensor, IR remote here. Firstly, we'll be having an IR remote and an IR sensor. Okay. So what we'll be doing with this now? So this is IR remote. It has 3 into 7, 21 pins and buttons, and every button has a unique hex code. So if I press this button or this button, it will send a unique hex code to to the surroundings, and this sensor will catch those signals. So and pass it to the pin I am telling just now. So it has three pins: one power, ground, and the third out pin. So the signals it will collect will send to the Arduino on pin number out. So we will connect out to Arduino and give positive and negative through this or this. And all these buttons have unique hex codes, so we can identify them, each of them easily. So we'll start making the connections of IR sensor here. Firstly, we'll connect the power to the positive and give it a red color. Negative to the ground, give it a black color. And we'll connect the out pin to pin number 13 here. So we can connect it to pin number 13 of our Arduino board. Okay. It is connected to pin number 13 and we can give it any color. Let's switch time. So now IR is connected positive to power to positive, ground to negative, and out to pin number 13 in my Arduino board. Okay. So now let me give a summary what have we done. We have set up an LCD display here with the help of breadboard and Arduino, and now we are setting up an IR sensor with, and we have IR remote here which has 21 keys and all of them have an unique hex code. So after pressing the button it will send signals and this receiver, IR receiver, will connect the signals and send it to the out pin, that is pin number 13, which we are connected to Arduino pin number 13. So we'll write a code here to see the functioning of this IR sensor and making our remote ready. So for this IR remote, we have one library named IR remote. I'm including that now. So IR remote. So I have included an library name IR remote. After that, we'll set the pin which we have connected to the receiver. So like I have connected the pin to the pin number 13 in my Arduino board. So I will set the pin. So I will make an integer just as we make in C++ or C and name it anything you want. You can name it anything you want. I will name it as IR receive pin. Like it is receiving the input. Okay. Or we can, like I have connected to pin number 13, we can connect it to pin number 10 also. So I think pin number 10 will be more useful if we connect it to pin number 10. So I am making an integer IR receive pin and give it in the pin number 10 I have connected to it. Okay. So I have set it up the IR receive pin an integer. After that I will include an object from this library from from a class of this library, that is IR receiver. So this is the class name which is from this library IR receiver, and I am making an object namely IR receive with the pin number I have declared before. So this is the pin number. We can write it 10 here, but I have declared a pin number, so we can use the variable here. After that, for decoding the results, like it will send some signals, so we have to decode it. So we have a object name or class name decode results, and we can make an object of that. So we can make an object of that, like this is the class name decode results, and we have made an object namely results. So we'll decoding the results using this. Decoding results means like it has received some signals. So now we have to convert the signals into the code which we can understand or which Arduino can understand. Okay. So now after that declaring all the variables, we will come back to our setup. So now we have set up the LCD display before. Now we'll set up the receiver. So I will make this receiver open to input. So I will enable it. So this is the command using which we can enable. So this is IR receive that I name that the name I given before. You can name it anything from your name or anything you want to. So I have given it IR RECV. You can name it as it, and I am enabling it, enable IR in, like it is open to input. Oh, we can, if we press any button it will take that input. So I am enabling that. Now all my setup is done. Now what has to be done continuously, like it should receive. Now what should be done uh, continuously. So we have in the loop, we will check if there some signals come, like if this receiver decodes any signal, then what should be happen. So for that we will be writing if condition here, same as C++ or C. So in this if condition we will be writing if our receiver, that is IR RECV, decodes any results, IRCV decodes any results, and it will save to the variable we made before results to that hash. So like you have a scanf statement in C in which you give the variable here and scanf item, scanf input is saved in those variables you have saved here. So similar to that, the results will be saved in this variable and we can use it later on. Okay, so after if the signal comes, so we will set the LCD clear, like we'll clear the LCD, like there should be nothing. So LCD dot clear, we'll be clearing the LCD first. After that, we'll be printing the LCD with the results we have found in when a button is pressed. So we'll write LCD dot print, and in the bracket we'll write results uh, dot value comma hex. We want the results in hex form. Okay, so after that we'll resume the IR receiver, IR RECV, that it is open to new inputs. Like if we don't do this, like if we don't do this statement is very important, because if we don't do this, then it will save the first result and never go again. So we have to resume the IR receive, that if any another signal after this comes, you are open to that. So I have made this. Now we'll test that our uh, receiver and remote are working fine or not. So I have started the code. So now system started. Now I'll pressing power button. So I am getting the code of the power button. Okay, and if I press any other button, you can see I am pressing now volume plus button. So the volume plus button codes come here, and you can press any button and the code of that button will come hex code. So we'll be noting some of the buttons hex code because we are going to use them in our forward workshop. So first there is a we'll note the hex code of power button. So there is FD00FF. So I'm noting it at my register here. You can also note. Now volume plus button has this code. I've noted it. Volume minus button, uh, right button, left button. Okay, so I have noted them on my register. Now we are making an car. So generally we need.
एक्सक्यूज मी सर, सर एक बार कोड दिखाना दोबारा. ओके सर, ठीक है, थैंक यू.
Okay, so now we are making an car, the circuit of car. So we will make it move forward and backward. हम आगे चलाएंगे और पीछे चलाएंगे. So and we'll turn it right and left. So we generally require four buttons for forward, backward, right, and left. So we'll be using volume plus button as forward, volume minus button as backward, right button as right, and back left button as left. So this is I have noted all the hex codes of all hex codes of all these buttons. So now we'll be starting with our motors. Okay, so we'll be applying two motors here. First one is simple DC motor. Here we have the DC motor. This motor will help us in moving forward and backward in a car. Okay, so it has generally two terminals, and we can give any terminal positive and any terminal negative, and if a potential difference creates across these terminals, the motor will start rotating in the direction of the direction. Like if I give the positive here and negative here, then the motor will start rotating in clockwise direction. And if I give uh, this negative and this, that is vice versa, then the motor will turn in anti-clockwise direction. So we can control this motor by giving reverse polarities. Now for steering our car, we'll be using an servo motor, that is micro servo. You can find it here. And this is not like a general motor. In this motor, there are three terminals. First one is positive power, that is then ground negative, and it also have a signal uh, terminal. So in this DC motor which we have before, we generate a potential difference. Okay, so this works on the potential difference. But in this servo motor, we gives it degrees as input in the signal so that it can move towards some degrees. Like I will give it degrees 20, then its position will change to 20 degrees. And it doesn't work on potential difference, it works on degrees, and its maximum limit is 180 degrees. So we can make it rotate only to 180 degrees. So now we'll be making the circuits, connecting our motors, and then writing the code to make our car run. So first of all, we'll be connecting our terminal of servo motor of DC motor to breadboard. terminal and give it in an color. Okay. Connecting second terminal to the breadboard. Okay. So now after connecting these, we'll be operating our motor with the terminal pins 6 and 7 here in the Arduino. So we'll be connecting these pins to 6 and 7. So connect it to pin number 6. Okay, so I've connected these to pin number 6 and 7 of our Arduino. So our DC motor is ready. Now we'll connect the power of our servo motor to the positive terminal and give it a red color. Ground to the negative terminal, give it a black color. Now after that, we will be connecting the signal button of our servo motor to pin number 13 of our Arduino board. So I can make a connection from here, pin number 13 in my Arduino board. So you can make it, give it any color during this time. So this will transfer the signals to the servo motor. So are you clear that this motor will be responsible for forward and backward movement of a car, and this motor will be responsible for steering. Shankar servo touch. Servo touch, and we'll make an object, namely my servo, using a class servo which is defined in my servo.h. To have make an object, namely my servo. So now we'll define an integer that is position, initial position of our servo motor. So as I told you before that servo motor can rotate up to 180 degrees. So we'll set up the initial position of our motor as 90 degrees. So that if we want to go to right, then we can go to 0 side, and if we want to go to left, then we can go to 180 side. So we'll position it the motor in 90 degrees in the starting. After that, on the press of button we can change it. So I'm giving position, and after that all the declarations for the motor are done. Now we will attach the motor in the setup part. Like I will attach my servo dot attach. It is the function given in the servo dot h library we have included, and in the bracket we will write the pin number we have attached the R motor. So I have attached our motor to pin number 13. You can see here in our Arduino. So I'll write pin number 13 here. Okay. Now our servo motor is attached to the Arduino board. After that, we'll write my servo dot write, and we'll write the position in it, like starting position. So we have defined it to 90 degrees. So I have written the pose here, position here, so that it will set to initial position. So my servo motor is successfully connected. Now we will connect our DC motor. So DC motor does not require any special library because we can operate it from simple battery, giving it in giving giving it a positive and negative. So we'll just use two functions, namely pin mode and digital write. So as Lily told you before, pin mode function is used to define the input or output behavior of an pin. So we'll be defining 6 and 7 as pin mode output. Okay, and our DC motor is also ready now to start with. Okay, so now we'll be start controlling our car from the remote. We'll start writing the code for that. Okay, so first of all, we will find that if any results come, then LCD should clear and it should print the results. And now, if the results we got, like if we'll write an condition here, if that results value results dot value we have used before in the hex form or is equal to 0 comma or 0x. It is the convention of writing an hex code. So the code for we have noted before, the code for power button or the volume plus button we'll using first. So the code for volume button was FD8075. So we'll be writing FD8075. Okay. So this is the, if this is the result value, like if we are pressing the positive button, then what should be done? So we'll be digital writing in our motor. Digital write is just Arduino function which will do the current pin that is given here, that is like 7 here. It will give 1, like 1 means high, so it will give positive to 7 and 6 negative to 6. So my motor should have a potential difference and it should start rotating. Okay, so I will start the simulation and check if is everything fine or not. So now on the positive button, when I press the positive volume plus button, I will show you again. Now my system started and I am pressing the positive button. So after pressing the positive button, my motor is started rotating on a fixed RPM, that is 3846 RPM rotations per minute. So it is moving in forward direction. So our code is working fine till now. So our positive direction is ready, and we have a limitation in our code in our IRA mode. I would like to show you, like if I press वॉल्यूम बटन वंस, अगर मैं एक बार दबाऊं तो उसका कोड सही आता है यहाँ पे डिस्प्ले में। मैं कोई भी बटन एक बार दबाऊं तो उसका कोड सही आता है, पर मैं उसको अगर दबा के रखता हूँ, जैसे मैं वॉल्यूम को दबा के रखा हुआ है, तो एफ 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 आने लग जाता है। और इसको बोलते हैं हम और सो कंडीशन कि रिपीटेड सिग्नल बहुत सारे आ गए तो वो फिर FF दिखाने लग जाता है, आप कोई भी बटन दबाओ तो मैंने अभी वॉल्यूम माइनस दबाया, आई हैव प्रेस्ड द वॉल्यूम माइनस बटन एंड इट्स शोइंग FF। इफ आई प्रेस एनी बटन, मतलब मैं दबा के रखूँ किसी को भी तो FF दिखाएगा मेरे को. So we have to sort this overflow condition first of all. So we'll define an unsigned long first with the name last code. तो हम क्या करेंगे, देखेंगे कि जो हमारे पास लास्ट कोड आया था वो क्या था कंटिन्यूसली दबाने से पहले, तो हम उसको एज इनपुट मान लेंगे. So I have defined an unsigned long here last with the name last code. Okay, and in this, before going forward, we will be defining the last code condition. If FF comes, then result value should be last code. So if result value which which is coming from the receiver is FFFFF, then the result value should contain the last code which we received. Okay. So now we'll making the positive and negative direction of a car. So if I can, so I will write starting right in with some comments so that we can understand what we are doing. So if top button pressed means a car should move in a positive direction, means forward direction. So I have done these positive, one positive, one negative. So it will start moving in forward direction, and we will save the last code here. Like इसके बाद अगर कुछ दबाया जाए तो लास्ट कोड में ये सब हो जाए. लास्ट कोड इज इक्वल टू रिजल्ट डॉट वैल्यू. Okay, so now our results value are ready. Now we will define an else if here कि या तो गाड़ी आगे जाएगी या तो पीछे जाएगी, तो हम इसको else if में डिफाइन कर सकते हैं. Else if results value, or we can copy whole the else if here. Okay. So now if bottom button pressed, or you can say volume minus button, you can say volume plus button, nothing more. So if volume plus button pressed, so we are giving here 7 in the top button, 7 positive and 6 negative. So we'll giving the reverse here in, so that our car should move in the reverse direction, and everything else remains same, and we will change this code of with the volume minus button code, that is FD 906F. Okay. So now our positive and negative are ready. Now we'll be making our car turn right or left. Okay, so we'll copy this, if paste it here. So now if results value for left are, like I will change the first of code. For left button their code was FD 2020DF. This was the code when left button was pressed. So in this we don't write digital right, we'll be controlling our uh, right and left motion with our servo motor, as I told you before. So we'll write my servo as I defined the my servo motor as my servo at above here. and enabled it and at pin 13 and return a position here, initial position given 90 degree. Now I will give it the position we want to give it for rotation. So my servo dot right, and for the left button uh, we'll enter 180 degrees. So if we want to turn our car left, we'll go towards 180. Like फर्स्टली वी आर एट 90 डिग्रीज, हम पहले 90 पे हैं. जैसे ही लेफ्ट बटन दबाया जाए तो मोटर जो है 90 डिग्रीज से 180 डिग्रीज की तरफ जाने लग जाए तो हमारी कार जो है लेफ्ट टर्न करेगी. एंड लेफ्ट बटन प्रेस. ओके, नाउ we'll write similar else if and copy this or else if right button is pressed, then our car should go towards 0 डिग्रीज. सो अभी 90 पे है इनिशियली. जैसे ही राइट बटन दबाएंगे तो वो 90 डिग्री से 0 डिग्री की तरफ आएगी मोटर. सो हमारी कार राइट हैंड साइड मूव करेगी. और यहाँ पे हम उसका वो डाल देते हैं कोड, हेक्स कोड जो हमारे राइट के लिए था, FD609 609. So now our left and right are also ready, and we will give a delay after that. For some time we want to our car to be moved, so we'll give a delay of a very small delay of 15 milliseconds, that is 15 by 1000 seconds in both of them. So we'll give some time for servo motor to turn itself, and our right and left and forward and backward movement are ready now. So at last, now first we designed that if signal comes then this should happen. Okay, so now if no signal is present then what should happen? So we'll be writing that now. If there is no signal then what should happen? So copying this, control V, and so if no signal comes then equal to 0. If no signals come then what should happen? So we have written digital right here. We'll copy it, and first of all we'll clear the LCD first, that if no signal comes LCD should be clear. And then our motors which don't have signal, they both have to stop. So like if I give both negative then the motor will not move as the potential difference will be 0. Okay, so digital after digital writing, and we need a delay here. Like if there is no signal, wait for signal for 250 milliseconds. If no signal comes under 250 seconds then execute this. So we are giving a delay of 250 seconds here, milliseconds, sorry. Seconds is very large, so we are giving a delay of 250 milliseconds here. And at last we'll set our servo motor, that is the steering motor of our car, back to its initial position, that is pose, that is 90 degrees. So my car steering wheel will come back to its position when there is no signal. So this is the code for driving car. We'll test it now. That is everything going fine or not. So I have run the code. So I'm pressing volume plus button now. So my car is moving in positive direction as you can see, and here the overflow condition. Let's fix this. We have to print these results after. So now we start the code again. So I'm pressing the volume plus button now, and you can see our car is moving in forward direction. As soon as I release the button, the car speed goes to zero. So I will share my full screen so that you will be able to uh, see my cursor. So are you able to see my cursor now? So I am pressing the volume plus button now, and you can see the RPM of our motor. It is going in positive direction with a speed of 3846 RPM. And after I release the button, its speed goes to zero. And after now pressing the volume minus button, and my car is moving in negative direction with a speed of 3846 RPM. As soon as I release the button, the speed goes to zero. Okay. So this is the motor which will control the forward and backward movement of our car. And now I will show you the right and left movement. So I am pressing the right button and the servo motor is turning to right. And I am pressing the left button. So servo motor is moving towards left. So this is the steering motor which will control the steering of the car. So it will control the steering of the car, like we have to move it or something, and these buttons will control the speed of the car. It should move in positive or negative direction, which is to be. So this is how we can make a remote control car using Arduino. And we can also uh, put some LEDs and put some buzzer in that uh, using simple logics we have used until now. We can simply write digital right, and so we can control the LEDs of the car with the remote, and we can customize it as we want. We can implement some ultrasonic sensors to detect any obstacle which comes uh, before it, so that car should stop automatically, and we can define anything we want. With these are the components, we can implement any of the components here. So I have this is the model which have some LEDs and a buzzer also. So we can control these LEDs from this button, and so I show you the simulation of this. So if I click the positive button, then the positive car is moving in positive direction, and if I press the negative button, the car is moving in negative direction, right, left, and uh, if we want to glow the LEDs, then we can press the power button. So LEDs are glowing up. We can make any, we can play the buzzer also. You can do anything you want. So now Lalit will tell you how you can practice more on this. So this was all from my side. Thank you. If you have any doubts, you can ask me.
So thank you there. So I hope you understood the basic concepts that are involved in using an Arduino. So if you are interested in learning more about Arduino, here are some simple beginner level projects for you. For example, you can now try to how to add an infrared remote to the speaker system, make your own motorized camera slider, uh, s- a smoke detector using MQ2 gas sensor and Arduino, and traffic light controller, simple Arduino alarm system, and a buzz wire game, and many more. I will share a link with you in the chat box. So here you can check out these projects, and if you have any doubt, you can ask us. So that's all for today. Hope you guys enjoyed the session. Thank you.